record. All right. Okay. So Justin, welcome to Kentucky. We're so very excited that you can join us all the way from Texas. I'm going to do a quick introduction. Justin is a sustainable agricultural specialist with the National Center of Appropriate Technologies Southwest Regional Office. He has a BS in agronomy from Prairie View A&M University and an MS in plant breeding from Texas A&M University. Justin spent years figuring out the nuts and bolts of successful organic farming in the humid South. We're so glad you're with us. We need this. Concentrating mainly on sweet potatoes, strawberries, niche market, ethnic specialty crops, cover crops, and drought mitigation techniques. He's currently working on cover crop projects in South Texas to help farmers there build organic matter in their soil. So just a reminder, please put your questions in the chat for Justin, and it's all yours. Thank you.
All right, so I'm going to go ahead and get started. Thanks for that introduction. Share my screen. All right, so today we're going to be talking about how to use cover crops. Y'all can see the screen, right? Yes, all right. So anyway, we're going to talk about how to use cover crops to build resilient soils and income. And, you know, I hear a lot about cover crops, do a lot of presentations, but people are just starting to understand how important cover crops are again, because, you know, back in the days, back during during the Dust Bowl and all that, people figured out, hey, we shouldn't leave bare ground. We shouldn't leave the soil exposed to the elements, especially the wind and all that. So, you know, cover crops, you know, they're used to prevent erosion, and that's from, you know, wind, from water, all that sort of thing. They're used to build soil organic matter, and that's very important, as you'll see later on in this presentation. They help increase water infiltration and storage. And I have a lot of problems with producers saying, you know, that old saw that cover crops steal all my moisture. They steal all the water out of the soil. And so I refute that, because, you know, it comes down to your practices. If you're using cover crops and you're trying to terminate them using a disc, then yeah, you're losing water out of the soil, but it's not the cover crop's fault. It's the disc's fault, because you're opening up the soil to the elements again. So you've got to kind of understand how to incorporate your methods or change your methods to incorporate cover crops. It's really important to prevent solar radiation from touching the soil. And this goes back to the organic matter, but it also deals with the soil biology, because if there's nothing there to prevent that solar radiation from hitting the soil, then it's killing a bunch of stuff. It's, you know, the microbes and all that, they can't run away. They're just sitting there baking. So I'm sure you've done a pottery class at some point. Well, at least I did one in high school. You know, if you expose clay or whatever to heat, it's going to harden, and that's not a good environment for plants or other organisms. So, like I said, these were recommended after the Dust Bowl era. Y'all know about the Dust Bowl. This crazy folks out in the Midwest, they plowed up all their soil. The soil didn't want that, and so the wind hit it. But people kind of figured out after that, hey, maybe that's not such a good idea. So anyway, cover crops provide many benefits to cash crops in rotation. And, you know, it's not only the biology, but it's, you know, the mineral movements and all that. So one of the benefits is companion planting. And companion planting, you can incorporate into vegetable operations. I guess most of y'all are vegetable folks, right? maybe. Um, so if you're a vegetable producer and you take some of your production out of vegetables and put it into cover crops, you can use it as a companion plant, um, and kind of allow a space for your beneficial insects to live and all that. And also, if you're using cover crops that are legumes, you can help give that soil rest and allow it to build up some nitrogen and whatnot. Companion planting is considered a small scale practice, but it can also be practiced on larger parcels if you're doing what's called intercropping. The mechanisms of companion planting are extremely complicated because plants are like, and I get into this argument with vegetarians and vegans and all that because they feel like they can eat plants because plants don't have feelings. But I would say that plants do have feelings and intelligence and whatnot. It's just in such a way that we can't understand it. I call it the chemical consciousness, because if you've got one plant and it's being affected by aphids, it's going to emit chemicals into the air that let the other plants around it know that it's being attacked by aphids. And those other plants will start producing defensive chemicals just like if they were being attacked by aphids. So if they can communicate with each other, then and react and respond to each other, then there's got to be a little bit more there than we really understand. So these mechanisms of companion planting, of how different plants planted in close proximity to each other share these chemicals, like semiochemicals, and allelochemicals, and that sort of thing. They share these chemicals, and it's kind of interesting because, like, I've got a patch of blackberries next to some peaches, and the peaches tend to taste like blackberries. And so it's not just that the chemicals are flowing through the air from the blackberries to the peaches. There's another mechanism, and I'll get into it a little bit more later, but there's a thing under the soil called mycorrhiza that transfers phytochemicals from the blackberries to the peaches. So interesting stuff. So there's a lot of complication going on there, and we don't really understand it, but we can always benefit from it by just planting many different types of plants together. Farmers and gardeners have over the years developed combinations that work for them, and they've passed them down from generation to generation. People know that you can plant like onions and strawberries, or different things with radishes or nasturtiums, because they have a more pungent smell or taste. And so insects that are looking for one vegetable, they'll smell that other vegetable or crop or whatever, and the thing that they're looking for is masked by the thing that has a stronger scent. So gardeners have kind of figured out these things, and they've learned to do these companion plants. But it's generally scoffed at by science, and it's silly that science scoffs at it, because science knows these things work. Because the general body of scientific evidence supports companion planting. The problem is that all the links of the chain aren't seen as the chain itself, because there's a lot of over compartmentalism. People, they get embedded in their specific science or their specific vegetable they're studying, and they kind of don't look at this other stuff. Hopefully that's starting to change, because there's a larger sustainable movement and a larger regenerative ag movement. So some of that's starting to change. People are starting to catch on. And of course, there's been an over-reliance on chemicals. All these synthetics out there in agriculture that, I don't think they should be there. I don't use chemicals on anything I grow. I did my graduate work in cotton. They sprayed my cotton field, my research field, so many times it was just ridiculous. I mean, they spent so much money just spraying these fields, and we still had weeds, and we still had pests. So what's the point of spraying all this stuff if you can't control the things that you're looking for or you're trying to control? So when I started working for Prairie View as a greenhouse manager, taking care of their horticulture research plots and all that, I decided I would find a different way to do it. And most of what I found was that, using cover crops in rotation with my vegetables or fruits or whatever, really helped out with the weeds. It helped out with the organic matter. It helped out with the general health of the cash crops. If you want to know more, there's some ATRA publications, companion plants and botanical pesticides, which is one I wrote, and then one of my coworkers wrote, intercropping principles and production practices. You can look those up on the ATRA website.
Hey, Justin, can I
All right,
interrupt?
so
Justin, can I interrupt for a second? This is Brooke. It seems like your video is taking a lot of the bandwidth. Do you want to, we had discussed the possibility of you turning the video off during, perfect. And then just, if you can turn it back on during the Q&A, but for now, I think that'll be better. Thanks.
All right, so were y'all able to hear most of what I was saying, or was I just rambling off into empty space?
We heard it perfectly. It was just sort of like slowed down every now and then. So content wise, I think we're all up to speed, but it'll go smoothly without the video maybe.
Okay. All right. So one of the scientific things that they've done with companion planting is multiple trap cropping. And this is where you have a cash crop that is protected by several trap crops. And trap crops are crops that you grow so that the target pest, instead of going to your cash crop, he goes over to the trap crop. And once it's in the trap crop, you can deal with it. Multiple trap cropping uses either different trap crops or different physiological stages of a trap crop. So in this scenario, let's say that the crop is cotton. The trap crop, one is very young alfalfa or very newly mowed alfalfa. Trap crop 2 is vigorously growing alfalfa, and trap crop 3 is alfalfa that's about to be mowed. And what that does is it pulls different pests away from the cotton and attracts it to the trap crop, and you keep mowing these. So like trap crop 1 becomes trap crop 2, trap crop 2 becomes trap crop 3, and then trap crop 3 becomes trap crop 1, and you keep mowing those. And this is not to scale. You can have strips of the trap crops within your cash crop, and this way you're in a constant state of pulling the pest away from your cash crop. Another thing that I'm really excited about is push-pull trap cropping. And this is growing a push crop, or a crop that repels pests within your cash crop. On the outside, you have an attractive trap crop, something that pulls the pests, something that's delicious to the pest, but the pest may not be able to either complete its physiological life stages, or you can just easily control the pest in that trap crop. This was figured out in Eastern Africa. Once they figured it out, about 10,000 farmers adopted it within a 3-month span. It was really, really popular there. And one of the main things that they were using it for was issues with a weed we don't have, and I'm thankful we don't. It's called striga. Striga is also called witchweed. So they figured out that it works for reduction of striga as well as pests of corn, of maize. And I really don't think they should be growing maize anyway, because, you know, traditionally they grew sorghum, and for whatever reason, maize supplanted sorghum, and it just doesn't do well over there. But in any case, this is a really effective means of trap cropping. All right, so not only can you use cover crops as trap crops, but you can also use them as nurse crops. And this scenario is broccoli and clover. I love using crimson clover. And, you know, I think that crimson clover freezes up there where y'all are, but here we plant crimson clover in October, and it's ready to come out in like May or June. So in this scenario, what I do is the previous year, I've let the crimson clover go to seed. So it goes to seed, dries out completely, it's dead. I go through and mow it and shatter all that seed, and use a reciprocating spader to push all the I don't know, the residue underground. And then I grow I'll grow either sweet potatoes or cowpeas over the summer. In the fall, when I take the summer crop out and prepare the field, I just leave it for a little while. I prepare it like, you know, I'm gonna plant, but I don't plant anything, because the clover seed will start germinating. Once the clover seed starts germinating, broccoli transplants into it. Now, the broccoli transplants are a lot larger than the germinating clover, and they grow faster. So the broccoli matures, and as it's maturing, the clover is kind of filling out slowly, and we harvest the broccoli. But as that clover is growing and filling up the field, it's serving as a host site for all my beneficial insects. So the beneficial insects and spiders, they keep the broccoli clean. The only problem I would have is birds. They will go out there and you know, kind of sit on the broccoli and do their business on it, and then I can't use that broccoli head. In any case, but the arthropod pests, they didn't bother the broccoli, because there were always spiders or parasitoid wasps or syrphids or whatever living in the broccoli. I mean, in the clover. So they would keep the broccoli clean. So we would go and harvest the broccoli. Once we were finished, by the time we were finished harvesting broccoli, the clover had taken over the field. And so we just repeat that cycle. So the clover replants itself year to year, and we come through and transplant broccoli into it to you know, give that field all the benefits of a cover crop. This is a similar type situation. It's a more tropical country. They're growing some cycads or some I forget the name, sago palms. And in between, they have a cover crop called perennial peanuts. And perennial peanuts are not, you know, we wouldn't eat the seeds on them. We wouldn't roast them. Mr. Peanut would look at these and kind of reject them. So they're not that kind of peanut, but they are a great cover crop in that they don't have to be mowed. They only get about 4 inches tall. They enrich the soil with nitrogen, and you know, they're just a self-maintaining cover crop. So you can plant these in orchards or groves or anywhere where you don't want to have to mow. All right, so one of the services that cover crops provide is root zone modification. So if you look on the right hand of the screen or the picture, it says shaded, and this is under the canopy of the plant, under the cover crop or under a tree or what have you, anything that is covering, any vegetation that's covering the soil, that's the shaded side. So as you progress to the left side of the screen, it's exposed. And so this progression goes from more shaded to more exposed. And as that progression occurs, you have more debris on the shaded side. That debris is what breaks down into humus. And this is where your fungal hyphae, they live, and they kind of help break that stuff down. That's important because at fungal hyphae, a lot of it is mycorrhiza, especially if you have living roots in the soil. So mycorrhiza, they plow through the soil, they meet up with plant roots, and they form a symbiotic relationship. So they trade information, they trade chemicals with the plants. The plants give the fungus carbohydrate, the fungus gives the plants minerals and water. And so this is where the resilience comes in, because, you know, if you think about the size of the root ball of your average vegetable, say like a lettuce plant or a broccoli plant, it's not that big. You know, it might be about the same size of a head of lettuce. So it can only get minerals and water from that area. But if you've got the mycorrhiza present in the soil, the mycorrhiza extends that root system. So as long as there's living roots, and that's why, you know, I was putting that broccoli out there in those fields, so that I would always have living roots, so that the root systems of the plants would join with the mycorrhiza, and they would be extended to wherever the roots of the plants were, the fungal hyphae were. So now you've got root systems that are in effect like dozens of feet long. So that's a great situation, because if there is a minor deficiency in whatever mineral that the plant needs in that particular spot, that deficiency kind of lessens in impact, because now you've got fungus all through the field bringing minerals to that plant. Now, on the other hand, if you've got an exposed situation, you have less of that, because the fungal hyphae don't have anything to grow on. So there's less moisture, and there's less organic matter. Now, what this does is this affects the ambient temperature. And I'll talk about that a little bit more in a minute. But just understand that it's good to keep the soil covered with something green. So I know a lot of organic farmers have problems with weeds. Those weeds are kind of doing you a service. It may not be the exact service you want, but as long as they're keeping the soil shaded, they're doing a little bit of help along with the harm they do. All right, so soil organic matter losses. The cooler areas have more soil organic matter. And since I'm from Texas and y'all are from Kentucky, I would argue that y'all are a cooler area. Now, don't fight me if you see me, if you think that your summers are hot, but yeah, y'all are a cooler area. So y'all have a little bit more soil organic matter than us. I have seen soils in Texas with less than 0.5% of soil organic matter. That organic matter is more sensitive to loss at higher temperatures. So if you're in a cool area, you've got more soil, you've got soil organic matter, but as it heats there, that organic matter breaks down faster than the organic matter we've got here. But your organic matter up there and further up north is of higher quality and more helpful to the soil than our organic matter. Because a lot of our resilient organic matter is sticks. You know, it's just lignins. It's stuff the plants really can't use right now anyway. In a cool area, if the mean temperature or average temperature rises 1 degree Celsius, you expect to lose 10% soil organic matter. In a warm area, the same rise will only result in about 3% loss of soil organic matter. But again, we have less of it to lose in the first place. So soil organic matter and water retention. Soils maintain a large reservoir of water in their organic matter. The hotter it becomes, the more water is lost, but also the more organic matter is lost. The loss of organic matter leads to a loss of water holding capacity. So each time it rains, organic matter is like a huge sponge. It holds water. The more soil organic matter you lose, the less water your soil can hold. Very important point, especially if you're dealing with drought situations. The less water in the soil, the hotter the ambient temperature becomes. So it's a self-replicating cycle of heating, and it's like this huge spiral. I mean, it just keeps turning and turning, and it's really like it alarms me, because people are worried about really minor things when they should be worried about the tundra melting in Siberia and in Canada. Because when the permafrost up there melts, remember I was talking about how soil organic matter is more sensitive in cooler areas? That stuff is releasing like millions of tons of methane and carbon dioxide as that soil thaws. Now, when they talk about climate change, that's climate change. That's some scary stuff, and it's going to increase our temperature a lot. So worry about the permafrost melting in Russia, because that's going to hurt all of us. All right, so soil organic matter decomposition. In hot and humid areas, we need twice the inputs of organic matter to maintain fertility. That's not every year. That's every growing cycle. In a no-till situation, you lose about half the soil organic matter as you would see in conventional tillage. But using no-till, everything remaining the same in hot areas should equalize, but it really doesn't, because it's hard to incorporate it. So what do? You grow cover crops. All right, so soil organic matter disperses negative effects. We see that organic molecules bind to toxic soil minerals. And when I say toxic soil minerals, I'm talking about iron and manganese, I'm talking about aluminum, I'm talking about all these things that build up in the soil. Well, they're already in the soil in most places. Like in Jamaica, they've got lots and lots of free aluminum in the soil. Aluminum is highly toxic to plants. It's toxic to you too. So stay away from aluminum pots. I do other presentations and they talk about how the minerals affect you and all that. If you've got aluminum pots, throw that stuff away, because aluminum, it messes with your brain, and it causes a thing that's becoming really, really hard to deal with, Alzheimer's disease. And I'm not a doctor. I'm not treating, curing, or diagnosing any disease. I'm just, letting y'all know what research I've seen. So soil organic matter, it disperses these negative issues, these toxic chemicals, and it basically disarms, the free aluminum and all that. And it does that because soil organic matter is humus or humic acid, and it's this huge long chain molecule. Now this molecule grabs the aluminum and it kind of hugs it, and it keeps it from being able to be exchanged for other things in the soil. All right, so people get mad at me because I don't compost, but y'all up there in Kentucky, y'all can compost, it's fine. But down here, I don't recommend composting. And like I said, folks get mad at me, but it's okay. I can take it. Anyway, in hot areas, it increases the volatilization of nitrates and carbon from compost. Now, you start off with a big pile of organic matter, you compost it, and at the end of the process, you're left with this little bitty tiny pile of compost, because everything that can turn into gas and go away has done so. Another way of building soil organic matter is by using manure, but it's bulky and it's messy to move. And if you're dealing with strictly certified organic production, there's some regulations that you have to keep in consideration when you're using manure. So the best thing to build soil organic matter is your cover crops. You grow organic matter in place. There's no withdrawal period. If you use legumes, it adds nitrogen. It moves minerals from the subsoil into the topsoil. It increases soil porosity. It's pretty great. It's an awesome solution. And it also always keeps the soil covered up and protected from solar radiation. And there's different ways that you can manage it. You can mow and incorporate it. You can mow and mulch it, or you can use no-till. All right, so if you're gonna choose cover crops, you've got to think about some things. What kind of soil do you have? What's the pH? What's your soil texture? Is it droughty? Does it flood? Are there diseases in your soil? Are there diseases to your cash crops that you want to break up that disease cycle? You've got to understand your growing seasons and cycles. And this was, when I first got out of grad school and started working, this was the first thing that I really had to sit down and understand. Like when I could plant things and what they were doing at what times in the season, when weeds were coming out, when certain weeds were germinating, when they were going dormant, all these things you have to consider. Really, really observe nature and understand what is happening. Then reverse engineer it. Go back and say, okay, this weed is going to germinate at this time. So what do I need to have in place to prevent this weed from being able to germinate? What cover crop do I need to have in place to prevent this weed from being able to set seed and thus reduce its seed reservoir in the soil? What cover crop can I plant to interrupt the coming out of dormancy of Bermuda grass or Johnson grass or nutsedge? And think about these things. So a good example of this is for me is Austrian winter peas. Austrian winter peas and crimson clover. I use those, like I said, I plant them in October. They're ready, or they start nesting in or dying off in May or June. And the beauty of those two was that my main perennial weeds I was dealing with were Johnson grass, nutsedge, and Bermuda grass. So with Austrian winter peas, when they were highly active, the nutsedge was coming out of its dormancy. The Bermuda grass was trying to come out of its dormancy. Johnson grass was trying to come out of its dormancy. But lo and behold, there's this dense blanket of Austrian winter peas on top of it, and there's no light getting down to them. So since there's no light getting to them, they're trying to come out of dormancy. The temperature's right, the moisture's right. They want to actively grow, but there's nothing that they can fuel themselves with. And so I would let the Austrian winter peas just die, just completely die, and they would kind of compact down into a mat of dead vegetation that the perennial weeds really couldn't penetrate. I would leave that for a month or two and let the rain fall if it was going to fall, and just rot out all those propagules down there that were trying to live. Very, very effective means of controlling those weeds. Other thing you have to look at is what's your next crop? Is there allelopathy involved? Allelopathy is plants are at war with each other sometimes, and they can be bad neighbors and cantankerous and have the whole Hatfield McCoy thing going on. And allelopathy is a chemical means of suppressing other plants. So a good example of this is sorghum Sudan grass. It's great to have as a cover crop if you are going to plant onions afterwards, or another allium. However, if you're planting a broadleaf after sorghum Sudan grass, especially I think it was cotton or broccoli, one of those or both of those, there was a bit of an allelopathic effect. So you have to understand what crops are allelopathic to which cash crops you're trying to grow. The other consideration is equipment requirements. If you're a vegetable producer, going out and buying hay equipment might be a bit cost prohibitive. So you can look at different cover crops that you don't have to mow or maintain or anything like that. Or are you also going into a little bit of haying as a side gig? So think about how much these things cost. A good cheap cover crop that you don't really have to go behind and mow or anything like that is buckwheat. Then what I was mentioning about weed control. Think about your weeds, what you want your cover crop to control. And I touched on that already. All right, so, well, that's not true. I added some grasses because, I love legumes. I don't really like grasses. Personal choice, just over the years, using them as using cover crops in my production with vegetables. I'm just going to give y'all some handy facts. It's no means comprehensive. For more information, you can refer to the related publication, Cover Crops for Hot and Humid Areas, or Overview of Cover Crops and Green Manures. Before I get into that, I want to talk about inoculation, because if you're using legumes, it's best to inoculate, and it's best to understand your inoculum. There's a lot of information out there that's now saying that the store-bought rhizobium aren't really as effective as they should be. So keep that in mind. Rhizobium is a bacteria that forms in association with plant roots. Long time ago, it used to be a disease, but now rhizobium has developed a symbiotic relationship with its certain legume. So with clover, it has a certain rhizobium that it uses. Then peas has another rhizobium that it uses, and cowpeas and peanuts have a certain rhizobium that it uses. Now, remember I said it started off as a disease. So basically, if you take the wrong rhizobium and put it with another legume that it doesn't match, it will form a nodule, and nodules are where the rhizobium live within the plant roots. But if you break open that nodule, it will not be pink on the inside. You want your nodules to be pink when you break them open. That's when you know that everything's working right. Now sometimes they'll be like green or brown or whatever inside, and that's when it's like the disease state. The rhizobium is just using the plant, and the plant is not getting any benefit from it. Some of these rhizobium persist better in the soil than others and don't need to be applied to seed every year. Down here, our native rhizobium, our different native rhizobium species are good for cowpeas or peanuts. And I'll talk about that on some later slides. but they're also good for peas and vetch. I saw some people mention that they use vetch as a cover crop. That made me smile. So the important thing to understand is that it's a bacteria. It's alive. It needs something in the soil for it to live on. And in most cases, well, in all cases, rhizobium, if it's living in the soil, it without a legume, it is a saprophyte. It's just feeding on organic matter. So there's got to be some organic matter in the soil for this stuff to persist. If there's not, then you're going to have to reapply your rhizobium every year and all that sort of thing. And sometimes the rhizobium are more ephemeral, they don't last long, and they have to be applied to every seed, at each planting. All right, so something that y'all have to deal with, and I don't, is endophytes, because we don't have that mess down here. Endophytes are symbiotic fungus that live within certain grasses. They produce alkaloids that are toxic to grazing animals. It's found in tall and fine fescues, perennial ryegrass, and some others. It's toxic, so it causes livestock to have staggers. So one thing that Texas has better than Kentucky. Sorry. All right, so I also want to talk about some profitability. Folks, one of the barriers to adopting cover crops is people don't want to spend money on something that they don't see immediate profit from. And this has kind of been a thorn in my side, because I'm like, there's so many benefits these cover crops give you, but you just have to take a longer view to things. People don't want to take a longer view because they're spending money on it and they need to make their money back now. Well, I've got some graphics to let you know that you can make your money back now. So this is economic impact of raising cover crops, and you can see all the stats and all that. But let's cut down to these two down here: net profit per acre with cost share, and returns without cost share. And cost share is the NRCS or whoever, they give you a little money to help you pay for seed. All of these different farms, all of them saw varying degrees of profit per acre, even without cost share considered in. So you can make money grazing your cover crops. That's one method. This company, and they're bragging about their corn yield and all that. So you go down this list of total benefits. They also are in CSP, which is another NRCS program. They got a $40,000 check, and their net economic return for using incorporating cover crops was $300,000, or per acre it was $57. And this is a study out of Purdue. You're not always going to, you're not always going to make a monetary profit. And if you look down at the bottom for annual rye per acre, they lost a little bit. But if you look at them using cereal rye or oats and radish, they did make some money in their corn yield. So this is how the cover crops affected their corn. So maybe with the rye, there was maybe some competition or some allelopathy, because ryegrass is very, very known for allelopathy, or something was up with this annual rye versus the cereal rye, which are two different species. So you did see some benefits in corn production. So cover crops can be profitable to your vegetable crops, your grain crops, or your animal production. All right, so one of the cover crops that they're starting to use up there in Kentucky, per one of my former co-workers, Steve Deaver, he's using this at the University of Kentucky now. This is the most nutritious grain. If you ever get a chance to go to an Ethiopian restaurant, this is made in their injera, and in some places you have to make sure that you ask for non-gluten injera, and then they'll come out with the pure teff injera. And injera is like a pancake, right? It's like a sourdough a sourdough flatbread that people in Ethiopia eat with just about every meal. It is the most nutritious grain in the world because it's really, really tiny. So when you grind it up and make flour out of it, it's got everything in it. It's got the whole thing. Now, as like us, we eat wheat, and they do all this stuff to it, and they take the wheat germ off of it, which is the most nutritious part, and they make flour out of it and all that. So is like,
hey Justin, I just want to let you know there are 5 minutes left for content and then 10 minutes for Q&A. Okay,
I'll rush through these real quick.
No rush. I mean, we can incorporate it into the Q&A, but just wanted to time check.
Right. So teff is great, and it's becoming more popular in the U.S. I've grown it, and when it came time to harvest, I walked out there and I looked at it, and I was like, well, it's too small for me to harvest. So I went out there and got the tractor and just tilled it in. Anyway, it makes really fine stem, high quality hay. Kajan is pigeon pea. I'm trying to get this to be more popular here because our climate is warming up. And I just looked at the USDA hardiness zones. I am now in zone 9. I used to be in zone 8. I'm now in zone 9. So yes, things are warming up, and it's creeping. The heat is creeping up closer from the south. And as things get warmer, we need to start switching over and looking at these more subtropical crops and all that. This is one of them. It's mostly eaten in India. It's a great cover crop. I mean, when I showed it to producers down here, the first thing they saw was that it was still green and everything was dead from the summer heat. They were like, "Can I feed it to my cattle?" And then after the field day was over, they were pulling plants up out of the field to take back with them to transplant because they loved them so much. This is a great way of getting insoluble phosphate back mobile in the soil because the roots exude pycitic acid. That's what it looks like. Notice there's a little borer action in that top pod. I'm still working on that, trying to get the nutrition right to keep the pests away. This is one of my fields. It is weedy, but after the summer, all the weeds were gone, and all you see is a canopy of pigeon peas. And that's me in the pigeon peas. The great thing about pigeon peas is they get tall. This particular variety only gets about 6 feet tall, some cases 7, but everywhere else in that field was just bone dry. But under the canopy, the temperature was about 15 degrees cooler, and the soil was still moist because there was a rain a few weeks ago and all that. So it was still squishy underneath the canopy. Great cover crop. Next is cassia or Chemacrista. This is what it looks like. Y'all might have that up there. It's a native cover crop and a great pollinator for native pollinators. On the right, you see buckwheat. On the left, you see the yellow flowers. That's sun hemp, and the green the green mess in the foreground of that left picture is lab. Another good cover crop is Phaseolus or scarlet runner beans. That's what they look like. Those are related to the true true beans. So they use the same inoculant as those. Vigna radiata or mung beans, they make a great cover crop. You have to make sure that you get a vining type. And those are what people make bean sprouts out of, little green guys. Centrosema or soft butterfly peas, that's what they look like. They're kind of semi-subtropical vine. And then cowpeas or Vigna unguiculata, great cover crop. Especially, I love the iron and clay peas, but you have to find a good strain of iron and clay, because for whatever reason they don't. Some that I've bought lately, they haven't vined out as much, but they crush vegetation during the weedy vegetation during the summer. That's what that looks like. Crotalaria juncea or sun hemp, they fix about 300 pounds of nitrogen per acre, about 5 tons of dry matter. They attract beneficial insects, so it's pretty good to have those in your vegetable crops. They use the same inoculant as the cowpeas. That's what the looks like again. Dysmodium or silverleaf Dysmodium and roots at the nodes. It's native to South America. It's not suitable for clay soils, and it doesn't like dry periods, but it'll live. It's not as palatable to livestock, but it helps control Hemp contortus, which is one of the intestinal parasites. That's what it looks like. Lab. A lot of people are starting to grow lab because it attracts deer. I've always liked it because it was a nice ornamental. It makes pretty purple flowers and purple pods. The purple pods are edible when it's young. I like multi-use cover crops because if you can make a little money off a cover crop, then why not? Especially like Austrian winter peas. Pea shoots are $8 to $15 a pound if you can find the right folks. They used to grow a lot of Mucuna pruriens or velvet beans across the South, but people stopped because that's what itching powder is, and it was a hazard to work with. But now they have non-itchy forms. That's what velvet beans look like. Then I did that one already. Scarlet runner beans again for whatever reason. Some other cover crops for your consideration are clovers, fescues, radishes, turnips, mustards, fava beans, birchfoot, trefoil, alfalfa, medics, ryegrass, Austrian winter peas, sainfoin, triticale, lentils, vetch, all sorts of stuff. And that special thanks to USDA because they gave me a nice CIG grant. And ATRA is funded through the Rural Development Program of USDA. ATRA is, okay, so I work for NCAT. ATRA is our program. It's our Sustainable Agriculture Information Program. You can call us up and ask us whatever random organic farming question you've got. That's what we're here for. And you can email me at justind@ncat.org. And also make sure you look for the corresponding publications in ATRA. All right, that's it.
Yeah, so much good information. Thanks so much, Justin. Let's bring you back. Let's bring you back into the video for the chat. If you can stop your screen share there.
Oh, how do I do that?
So thanks so much for all your questions, folks. We have those in the chat, and if you still want to get your question in, you can do that now. Let me go to gallery view here so I can see everyone. Thanks there. I recommend for y'all going to gallery view too. We'll keep Justin's video pinned, so he's going to be up there in the top corner for y'all. So we have a lot of questions. This session is scheduled to stop at noon. We don't have anything scheduled after it, so I'm going to propose that we just go to 12:05. So we'll have the full 10 minutes for questions. If anyone needs to hop off, go for it. We'll have the recording you can come back to. But I'm just going to start at the top. In the meantime, if you have more questions, drop them in the chat. Can you give us an example of a trap crop or push crop scenario? What things would you put in that scenario?
With the push crops, there's all sorts of stuff. So like you would have to name like the the crop that you're looking for. Because what you would need to do is find the target crop that you're looking for. Like I know like sugarcane is one example. So sugarcane, you plant that, and then you plant, you know, something within that you that repels the cane weevils and stuff like that. Then on the outside of it, you plant like switchgrass or something, or sweetgrass, or, you know, not sweetgrass, what sweet sorghum, or something that the pests they could live on, but they can't complete the life cycle on, or that just draws the pest away. So it depends on the crop. Email me that question so that I can and put in your specifics. That way I can better help you.
Great, thanks. Can you walk on that peanut cover crop that you showed us? Is it suitable for pathways?
You can put it on pathways if you're not going to tread on it too much. It'll take some treading, but I wouldn't just try to wear a trail through it, you know.
Yeah. There was a comment in the chat that Ladino cover a clover would be similar and perform well here. So there are some clover varieties that would perform well in the pathways. Okay, so now we get into the weed management side of this. What cover crops can help combat bindweed or Johnson grass? Obviously, those are going to be separate, but if you can get into that part of it.
I touched on Johnson grass in the narrative. I like Austrian winter peas for that, but in addition to the cover crops with Johnson grass, since it is a really robust perennial weed and it's got that rhizome, or it needs to dry out. And the way I do that is I hit the field with a reciprocating spader, and that pops up most of the roots, gets those in the air. I wait until either the hottest, driest part of the summer or the coldest part of the winter, and run over the field with the reciprocating spader, and that gets those roots up in the air and kills them. If you're using just straight cover crops with the Johnson grass, you're going to have to come in really, really hard in the fall with mow the Johnson grass as close as possible. Prepare your field, put some Austrian winter peas out there, and, you know, make sure that those Austrian winter peas just really, really fill in. I don't think they'll frost kill up there. I don't think they'll frost kill in Kentucky, but make sure you just really get those Austrian winter peas to fill in and get as big as they can, and then just let them die. And that way you can interrupt that Johnson grass cycle. With the field bindweed, it's really, that's another one I would use a reciprocating spader on, because that one climbs. The way that you kind of get around those climbing weeds is you have to have something that climbs a little bit better than it. The problem with that, even that, is like if you use cowpeas. Cowpeas would be one to try with that, and those would compete that same season. But the bindweed is even going to try to climb up out of that. So you have to have that canopy in place with something like Austrian winter peas when that bindweed is trying to become active. That way you starve it for life, starve it for light. But one big issue is that how much energy is in that storage root. Because it is like a sweet potato. It doesn't have as much carbohydrate in the storage root, but it's got quite a bit in there. So you have to keep it mowed, keep it suppressed through the season, and then in the winter or in the fall, come in with something that's going to prevent it from being able to acquire more light in the spring when it's becoming active, and then follow behind it with a really robust vining type of cover crop like cowpeas or mung beans or something like that.
Wonderful, thanks.
Uh-huh.
Okay, so question, is it too late to plant a cover crop in Kentucky this spring before summer crop is supposed to be planted? We know that frost seeding clover is an option. So what other considerations could folks have?
Wait, say that again?
Is it too late to plant a cover crop in Kentucky at this point? And I'm gonna say no. Frost seeding is definitely an option for some clovers here in the winter. Are there other recommendations that you would have for us?
The other one is that ryegrass, the annual ryegrass. That one still would germinate. I don't know how well or how much access y'all have to that, but
yeah, that's a popular
people
one.
use that as a cover.
Yeah. Any tips on removing very high level of phosphorus from the soil?
High levels of phosphorus from the soil. So y'all are switching gears to the bioremediation.
Well, just through using cover crops, is there an opportunity to address phosphorus levels and remove those crop residues from the field?
You could try sunflowers. Sunflowers absorb a lot of everything. So that they're one of my favorite bioremediators.
Great.
And they're also a pretty tough cover crop too, because they make a pretty dense canopy once they're up. In fact, we've got a weedy sunflower down here that'll make you tear your hair out.
Yeah, we don't want that one.
No, don't do that. I won't send y'all care packages of Texas sunflowers.
Yeah, no thanks. Okay, so getting to the end here, what would you recommend are the best resources for cover crop selection in terms of variety and timing? We dropped the link to all of the ATRA publications you shared. Is there sort of like a go-to how-to that you recommend?
The go-to would be they've got one. You said you put the SARE publication in there, the Managing Cover Crops Profitably.
We have that one. Yeah, we can drop it in there again. That's a great one.
Okay, that's one. But on a more local level, I would check with your extension people or your local NRCS people, and they can fill you in with that. Your seedsmen, they would be a great help. Your like down here, we've got Tractor Supply or the local feed stores. You can talk to them. Now, understand that they're also going to try to sell you something, but make sure that you follow up with whatever they tell you and make sure that it's right and they're not just trying to get rid of old seeds or something.
Yeah.
Now, somebody, I see a question that says, is pigeon peas something you would try in Kentucky? We've got a variety that, how long is y'all's growing season? Your hot growing season?
Hot growing season? I mean, May through October.
Is it more than 6 months?
Yeah.
Yeah. We've got a variety called GA2. GA2, it starts setting seed in 3 months, in 90 days.
Okay.
So y'all could do it. It's a if you're gonna try pigeon peas there, you're gonna look for a determinate variety, not an indeterminate variety, because the determinate varieties, they're gonna flower more or less all at the same time and in a big flush. Now, GA2 performs differently in Texas because it's indeterminately determinate, whereas it'll do its thing in 3 months, and then if it gets some more rain, it will flush out again and keep bearing. So it'll lose its determinacy and become indeterminate
down here in Texas. But up there, GA2 would live on in your season.
And what's a good source for the pigeon pea seed? What's your go-to?
You can try Hancock Seeds. Sometimes they have it. Sometimes Petra Seeds has it.
Okay, thanks for that. Well, we are at time. Thank you all for being here. Justin, thank you so much for sharing your expertise with us. So fun to connect. We're grateful. And if anyone has follow-up questions for Justin, drop them in the chat. We'll get them to him. You also have his email, so you can follow up with him directly. We'll share a PDF of the presentation, and so you can have it there. I do just want to go ahead and share my screen for some wrap up. With a couple of reminders. Please do take the session survey. It's rate this session back in Whova. Click on that button or go to the survey under the main navigation window. And you can click on any of the surveys for sessions you've attended. We'd love your feedback. It helps us improve for next time in terms of what you want at conference next year. But also we share that feedback with Justin. So please take the time to do that. Continue the conversation on all the community boards and the farmer roundtables, and go check out the virtual trade show. As always, talk with our vendors there. And just a quick reminder that we wouldn't be doing this without support from our conference sponsors. And stay tuned for 3 more sessions today, live sessions, 1 pre-recorded. We have Elizabeth Whitlow up next with from Regenerative Organic Alliance. And then she'll be starting at 12:55, and then Andre Fall and Jeff Maddox will be with us about organic pastured poultry at 2:25, and then we have our keynote speaker for today, Dr. Daphne Miller, at 3:50. These are all Eastern time, so please do tune back in, and we'll see you here in a little bit. So, Justin, thanks again so much. We're so grateful for your time and expertise.
All right, thank y'all for having me.
See ya.
All right, talk to y'all later.